Hello student, in previous class I discussed about the topic how can you write the name of the compound. These are some rules and also some examples I have given. Next I discussed about the stoichiometric calculation, and this is an example how the reactant and products are related. Here I have given the reactant and products are generally expressed in terms of molecules, Avogadro's number, moles, mass, volumes. I have given a homework to all of you. I have given an equation. Let me solve the equation. In the previous class, I have given a homework, that is your hydrogen react with the chlorine. Hydrogen react with the chlorine form hydrogen chloride. If I will balance, then this gives to HCl. Suppose I want to write in terms of molecules. Suppose I want to write in terms of molecules. Then how can I write here? This is your one molecule. So here I can write one molecule of hydrogen. Here also I can write one molecule. Next here I can here write two molecule. Next I want to express in terms of Avogadro's number. It can be possible by just looking the coefficient present in the reactant or product. Here only one hydrogen is present, so here I can write 1 into 6.022 into 10 to the power 23 molecule. Here I can also write 1 into that is your 1 into 6.022 into 10 to the power 23. Next here I can write 2 into 6.022 into 10 to the power 23. Next, in terms of moles, I can write here that is your 1 mole. Next, this is your also 1 mole, and this is also 2 mole. Next, I can write in terms of mass. That is here all are present in the molecule. So I can write the molecular mass here. So here I can write 2 gram. Atomic mass of hydrogen is your 1. Molecular mass of hydrogen is your 2. So here so here I can write 2 gram. Next I want to write the chlorine. Chlorine have atomic mass is your 35.5. Here the molecular mass is your 71 gram. That is your 71 gram. Now I want to think about the HCl. Here I can write 2 into molecular mass of HCl. Molecular mass of HCl means atomic mass of chlorine plus atomic mass of hydrogen. That means here I can write 36.5. Now here I can write 36.5 into 2. If you multiply, then what is the value? 0 or 2 into 6 means that is your 12. Here 1, that is your 13, 1, that is your 73. 73 gram. Next, you can also explain in terms of volume. The volume must be written at STP condition. Here I can write 22.4 liter. Next, here I can write also 22.4 liter. Then here I can write 2 into 22.4. That means here I can write 44.8 liter. This is the different relationship by using the stoichiometric calculation. And the different types of stoichiometric calculation. There are generally we used four stoichiometric calculation. One is the mole relationship. Another is the mass relationship. Next is the mass and volume relationship. Last is the volume relationship. At first, I want to move to the mole relationship. That means both reactant and the products are given in the moles. Look at that. Take a problem. Calculate the number of mole of hydrogen gas produced when 18 ml of iron react with the steam to produce Fe3O4 and hydrogen gas. Look at the question again. Here, how many number of mole of hydrogen? That means our target to find out the mole of hydrogen. Hydrogen. Our target to find out the mole of hydrogen. How much hydrogen I can get produced when 18 mole of iron react with steam. That means here the reactant is the iron, steam means that is your hot water, that is your H2O, and the product is your what? Fe3O4, and another is your hydrogen gas. So here I can write at first I can write here Fe. The two reactant are, one is the iron, another is the water molecule. So here I can write Fe plus H2O, and the product are what? Fe3O4, and another is the hydrogen. If I will balance this equation, then I can get this 3Fe plus 4H2O gives Fe3O4 plus 4H2. After balancing the equation, it is very easy to write the relation. Look at that. This relation can be written by using the coefficient. For iron, the coefficient is your 3. For water molecule, the coefficient is your 4. For P3O4, the coefficient is your 1. For hydrogen, the coefficient is your 4. So if I want to see think about the iron, here I can write 3 mole. If I want to write about the water, here I can write 4 mole. Next, for a P3O4, I can write 1 mole. For hydrogen, I can write your 4 mole. This is the stoichiometric relation. This is the stoichiometric relation between the reactants and also reactant and products. In this problem, our target is to find out the hydrogen number of mole of hydrogen when 18 mole of iron is react. That means here in the question iron, our target to find out the number of mole of hydrogen. It is also not necessary to write this term, that is your 4 mole, that is your water. Our question is related between iron and hydrogen. So other parts it is not necessary to write. Again, I will repeat. In this question, the target is find out the hydrogen, and the given data is your iron. So another species, that is your H2O, Fe3O4 is not necessary to write. So the from the above equation, here I can say that 3 mole of iron is needed to produce 4 mole of hydrogen. From the equation, after balancing, after applying the stoichiometric calculation, mole calculation, here mole is given, mole is our target to find. So here I can write 3 mole of iron. 3 mole of iron produce hydrogen is your how much? 4 mole. If I want to find out for 1 mole of iron, produce how much? 4 by 3 mole. Next, our target to find out for 18 mole. So here I can write 18 mole of iron produce hydrogen is your how much? 4 by 3 into 18. If I want to solve this, then 3 divided by 18 means that is your 6. 4 into 6, that is your how much? 24 mole. So 18 mole of iron produce, that is your 24 mole. The answer is your how much? 24 mole. That means when 18 mole of iron react with steel produce Fe3O4 and hydrogen gas, then the amount of hydrogen gas released is your 24 mole. Next, move to the problem number 2. Here also mole is given and the target is find out the mole. How many moles of hydrochloric acid are required to produce 5 moles of chlorine gas by reacting with the magnesium dioxide? So for such type of problem, it is highly necessary to learn how can you write the chemical equation. If you clearly write, if you easily write the equation from the statement, then after writing the equation, you balance the equation and find the coefficient. After getting the coefficient, it is very easy to solve such type of problem. So from the sentence, from the statement, it is necessary to find the chemical equation first. Otherwise, such type of problem will create very difficult for you. For solving such type of problem, your target to find out a balanced chemical equation. After getting the balanced chemical equation, you can use the coefficient coefficient and make a relationship between the reactant and products. Look at that. Your hydrogen chloride are required to produce 5 mole of chlorine gas by reacting with the magnesium dioxide. That means, look at that. Here, chlorine is the product. Your chlorine is the product, and magnesium dioxide is the reactant. Hydrochloric acid is also reactant. Look at that. Here I can write MnO2. At first, I want to write MnO2. Next here I can write what? Here I can write HCl. And how many hydrochloric acid required to produce 5 mole of chlorine? That means here chlorine is the product. With magnesium dioxide means magnesium dioxide is also reacted. So initially I can write MnO2 plus HCl gives Cl2. But if you see the real equation, then the real equation is your what? MnO2 plus HCl gives what? MnCl2 plus Cl2 plus water. This is the real equation. But in the statement, there is no word of magnesium chloride, chloride and water molecule. Here no mention of magnesium chloride and water molecule. But you should know about how to write the chemical equation and balance the chemical equation. If you want to balance this chemical equation, this is our chemical equation, then we can get MnO2 plus 4HCl gives MnCl2 plus Cl2 gives 2 water. Now apply the relationship. Looking the coefficient, here 1 is written, so here I can write 1 mole. Here 4 is written, so here I can write 4 mole. Here 1 is written, so I can write here 1 mole. Here 1 is written, here I can write 1 mole. Here 2 is written, so here I can write 2 mole. Now, actually, all terms are not necessary. Here they look at that. How many moles of hydrochloric acid are required? That means the question mark is here. Our target to find out the mole of hydrogen chloride, and the data is given is your what? 5 mole of chlorine. That means here I can write 5 mole of chlorine. Means here the target is 4 mole of hydrochlorine required to produce chlorine is equal 5 mole. Sorry, here I can write here this term. Here I can how many moles of hydrochloric acid. That means this how many moles of hydrochloric acid are required to produce 5 mole of chlorine. That means here 5 mole of chlorine, and the data is your 5 mole of chlorine, but our target to find out the HCl. So from the above, it is not necessary to write the 1 mole for MnO2, not necessary to write 1 mole of chlorine, not necessary 2 mole of water. You can only write the write for HCl and chlorine, because the question is completely related with the HCl and chlorine. So from the above I can write here 4 mole of HCl, that is your hydrochloric acid, are required to produce how much? That is your 1 mole. 1 mole of chlorine. So here I can change the question. How much? 4 mole of hydrochloric acid are required to produce how much? 1 mole. Again I want to say here I can write 1 mole of chlorine. That means if you take 5 mole of 4 mole of HCl, then 1 mole of chlorine gas is produced. If you want to take 1 mole of hydrochloric acid, then the amount of chlorine produced is your how much? Chlorine produced is your how much? Here 1 by 4 into 5, that is your 5 by 4. Here if you want to solve this, then what is the value? 1, 10, that is your point 2, that is your 8, next is your 20, that is your 5, that is your 1.25 mole. 1.25 mole of chlorine gas is liberated. How many moles of sorry for the production of for the production of 5 mole of chlorine we need 1.25 mole of 1.25 mole of HCl. Again I want to see that what is the problem here. How many moles of hydrochloric acid are required to produce 5 mole of chlorine gas? This is the relation MnO2 plus 4HCl gives MnCl2 plus Cl2 plus water. Here one magnesium. There are two oxygen. Here also two oxygen. Four hydrogen, four chlorine. All are balanced. In this equation, all are balanced. Again, I want to see the. I want to verify this. 1 mole, that is your 4 mole, that is your 1 mole, 1 mole, this is your 2 mole. Uh, how many moles of hydrochloric acid? This means this is the question mark. Are required to produce 5 mole of chlorine gas. This is the given data. Target is to find out the HCl. So here I can write 4 mole. 4 mole of hydrochloric acid are required to produce 1 mole. Yes. Our target to is your how? That is your 1 mole. 5 mole. Again here I want to change here. Again I want to check here. I can write 1 mole of chlorine is here I can change 1 mole of chlorine is produced by using how much 4 mole of HCl. Now I want to say that 5 mole of chlorine is produced by using HCl. By using HCl is equal to how much? 4 into 5, that is your 20 mole. 4 into 5, that is your 20 mole. Again I want to say that. Again look at the problem. Here MnO2 plus 4HCl gives MnCl2 plus Cl2. This is the wrong. What is the correct answer? I want to again say that 4 mole of HCl are required to produce. It is not necessary to write. Here you can see 1 mole of chlorine is produced by using HCl is your how much? 4 mole. 5 mole of chlorine is produced by using HCl is your how much? 4 into 5. 20 mole of HCl is required. Obviously, 4 mole produce 1 mole. So 1 mole. Here look at that. Here chlorine is given and target to find out the HCl. Look at that. Here 1 mole of chlorine is produced by 4 mole of hydrogen chloride. 5 mole of chlorine is produced by 4 into 5, that is your 20. So the answer is just like this. This is a wrong. You can write the simple thing only this. Look at that. This is the wrong. Look at that. This is the equation. This is the relation. This is the equation. Balanced equation. This is the relation. Here HCl is given. No need to write here 5 mole HCl. Here 5 mole chlorine. Again, I want to repeat the answer here. Look at that. How many moles of hydrochloric acid are required to produce 5 mole of chlorine gas by reacting with magnesium dioxide? Here the equation is your what? MnO2 plus 4HCl gives MnCl2 plus Cl2 plus water. This is the balanced equation. Here I can write the relation 1 mole, 4 mole of HCl, 1 mole of MnCl2, 1 mole of chlorine, 2 mole of water. Our target to find out the HCl. But here chlorine is given. Look at that here. Here 1 mole of chlorine is given. Here 1 mole of chlorine is produced by using 4 mole. So I have written 1 mole of chlorine is produced by using HCl. By using your HCl is your how much? That is your 4 mole. That is your 4 mole. Clear? 1 mole of chlorine is produced by using HCl is equal to 4 mole. Okay, look at the 4 mole is your 1 mole. 5 mole of chlorine is produced. 5 mole of chlorine is produced by using HCl is your how much? 4 into 5, that is your 20 mole. So the required answer is your how much? The required amount of chlorine, the required amount of HCl is your 20 mole. Next, move to the second relation, that is your mass relationship. Problem number 1, here mass is given and your target is found also mass. If you want to see the problem number 1, calculate the mass of iron that will be converted into oxide by action of 18 gram of steam on it. Look at that. Calculate the mass of iron that will be converted. That means the reactant is your iron converted into oxide, and the product is your Fe3O4 by the action of 18 gram of steam. That means iron react with the hot water on it. If you want to react with the iron with water, then no doubt Fe3O4 is formed. Also, hydrogen gas is liberated. So the equation is your Fe plus H2O gives a Fe3O4 plus hydrogen. This is the equation, but it is necessary to balance this equation. If you want to balance this equation, then you will get 3Fe plus 4H2O gives Fe3O4 plus 4H2. This is the balanced chemical equation. If you want to express the equation in terms of weight, here I can write atomic mass of iron is your how much? 56. So here I can write 3 into 56 gram. Next 4 into 18 gram. 18 is the molecular mass of water. Next here I can write how much? 3 into 56. There are 3 iron atom. Atomic mass of iron is 56. So here I can write 3 into 56 plus 4 into 16. Atomic mass of oxygen is 16. So here I can write 3 into 56 plus 4 into 16. And hydrogen having the atomic mass is your 1. Molecular mass is your 2. Here I can write 4 into 2 gram. Look at that, 4 into 2 gram. This is the main relation. Look at the again the question. Calculate the mass of iron. Calculate the mass of iron that will be convert. That means our target to find out the mass of iron, and the iron converted into Fe3O4 by the action of. It is not necessary write this term. Only write the for iron and water. Look at that. Here I can write 4 into 18 gram of steam is required. Here I can write 4 into 18 gram of steam is required to convert 4 into 18 gram of steam is required to convert iron to its oxide. Again I want to read the sentence. 4 into 18 gram of steam is required to convert iron to its oxide. That is your how much? 3 into 56 gram. Our target to find out the iron. So here I can write here for 1 gram of steam. 1 gram of steam is required to convert iron to its oxide. Is your how much? 3 into 56 divided by what? 4 into 18. So here I have written 3 into 56 divided by 4 into 18 gram. Now target to find out for 18 gram. So here I can write 18 gram of steam is required to convert iron to its oxide is your how much? 3 into 56 divided by 4 into 18 into 18. 18, 18 cancel. Here if I want to 6 divide 56 divided by 4, that is your 14. That is your 3 into 14 is your, that is your 42. So here I can write 42 gram. So here I can write again, and the answer is your what? 18 gram of steam converted 18 gram of steam is required to convert iron to its oxide is your 42 gram. So 42 gram of iron is treated with 18 gram of that is your water. Next, move to the problem number 2. Calculate the residue obtained on strong heating. On strong heating of 2.76 gram of Ag2CO3. That means here the reactant is your what? Ag2CO3. It is subjected to heating. After heating, what happens? Actually, the carbon dioxide and oxygen is formed, and the residue is your silver. Residue means the left things. Look at that. Here, three products are formed. One is your silver, another is your carbon dioxide, another is your oxygen. Both carbon dioxide and oxygen are gas, so they are away from the system. They left the system because they are gas. But here the silver is the solid, so the silver is present in the system, so it is considered as the residue. So the exact equation is your what? Ag2CO3. Ag2CO3, when subjected to heating, it gives 2 Ag, that is your residue, plus CO2 plus half O2. Then what is the relation? 275.75 gram. Silver having atomic mass, that is your 107.87. Ag for Ag2CO3, you can write 2 into 107.87 plus 1 into 12 plus 3 into 16. So if you add this, then you will get 275.75 gram, and the residue is your 2 into 107.87 gram, and the carbon dioxide is your what? 44 gram, and the oxygen is your 16 gram. Molecular mass of oxygen is your that is your 32. Your 1 by 2 means 1 by 2 into 32 means that is your 16. So here I can write 16 gram. What is the target? Here Ag2CO3 is given. That is your 2.76 gram of Ag2CO3 is given, and target is to find out the residue. That is your what amount of silver is produced. From the above relation, I can say that 275.7 gram of Ag2CO3 produces residue is your how much? 215.74 gram. This is the residue will be obtained by using 275.75 gram. If you multiply the 2 into 107.87, then there is your 215.74 gram. Now for 1 gram of Ag2CO3 produces the residue is how much? 215.74 divided by 275.75 gram. For 2.76 gram of Ag2CO3 produces residue is how much? 215.74 divided by 275.75 into 2.76. If 2.16 gram. So the answer is your 2.16 gram. So here I can say that 2.76 gram of Ag2CO3 produced a residue of how much? 2.16 gram. This is the relationship between mass and mass. Your mass is given and target is find out the mass. This first is the mole and mole relationship. Next, move to the third relation, that is your mass volume relationship. That means look at the problem. Calculate the volume of hydrogen liberated at a 27 degree centigrade and 760 mm pressure by treating 1.2 gram of magnesium with a excess of hydrochloric acid. What are the reactant here? You look at that. Calculate the volume of hydrogen liberated. That means your hydrogen belongs to product side. This is your one product. This is your one product. and the condition is your temperature is given, so that is your 760 mm. By reacting with the 1.2 gram of magnesium, that means your magnesium belongs to the reactant with the excess of hydrochloric. Hydrochloric is the reactant. So here I can write what? Magnesium plus HCl, and the product is your what? Hydrogen. Another product is also formed, that is your MgCl2, magnesium chloride. If you want to balance this equation, then here you can write Mg plus 2HCl gives MgCl2 plus hydrogen. Look at the relation. Your atomic mass of magnesium is 24. So here I can write 24 gram. If you think about the volume of hydrogen is 22.4 liter at STP. That means 24 gram of magnesium is used to produce 22.4 liter of hydrogen at STP. Here is what is the question? 1.2 gram of magnesium is given. It is treated with a hydrochloric acid. Then what amount of hydrogen gas is produced? So here I can write here 1.2 gram of magnesium, and here is the question mark. The question target is to find out the volume of hydrogen. Look at that. From the above, here I can say that 24 gram of magnesium produce hydrogen at STP is your how much? 22.4 liter. 1 gram of magnesium produce hydrogen at STP condition is your how much? 22.4 divided by 24 liter. Next, for 1.2 gram of magnesium produce hydrogen at STP is your how much? 22.4 divided by 24 into 1.2. If you want to solve this, then the volume is your 1.12 liter. This is not answer. Remember, this is not answer, because the gas is this gas, the amount of hydrogen produced, that is 1.1 liter of hydrogen, is collected under the temperature to 27 degree centigrade, and pressure is your the 1.12 liter of hydrogen is produced at STP condition. That means the volume of hydrogen is measured at STP condition. So this is not answer. Actually, here the question is calculate the volume of hydrogen liberated at 27 degree centigrade, and the pressure is 760 mm pressure. Again, I want to say that 1.12 liter is the not answer, because here the volume 1.12 liter is measured at a STP condition. So here you cannot say that 1.12 liter is the answer. So here it is necessary for 1.12 liter at STP condition to the amount of volume at 27 degree centigrade and 760 mm pressure. But this volume to this experimental condition. So here I can apply the combined gas equation, that is your P1 V1 by T1 is equal to what? P2 V2 by T2. Look at that. Here I have written given condition. Given condition, another is your experimental condition. Pressure P1, that is your 760 mm. Given condition and the temperature T1, that is your 27 degree centigrade, is equal to 300 Kelvin. Volume is your our target. But the STP condition, if you think about the STP condition, this is the STP condition. In STP condition, pressure is your 760 mm, temperature T2 is your 0 degree centigrade, that is your 273 Kelvin. Volume already here given 1.12 liter. Now apply the combined gas equation, that is your P1 V1 divided by T1 is equal to P2 V2 by T2. Put the value of P1. P1 means your 760. V1 is your our target. T1 is your 300. So here you can write 300. Next, P2 is your 760. V2 is your that is your 1.12. Next, T2 is your 273. So here you can balance like this. Here the equation is like this: 760 into V1 divided by 300 equal to 760 into 1.12 divided by 273. Cancel say 760 to 760. Next, how much? Here we can say that V1 is your how much? Here we can say that 300. Look at that, 300 into 1.12 divided by 273. So the answer, if you want to solve this, then the answer is your how much? 1.23 liter. This is the answer. 1.12 is not the answer. Your 1.23 is the liter. In this question, the relation is applied only STP condition. After getting the volume at STP, you will convert into the given condition. That is your experimental condition. So the answer is your 1.23 liter. Next problem, calculate the volume of carbon dioxide at STP evolved by strong heating of 20 gram of calcium carbonate. Here the reactant is your what? Calcium carbonate, CaCO3. It is subjected to strong heating. This is the heating. Then calculate the volume of carbon dioxide. The carbon dioxide is the product. Here actually given is your CaCO3 under strong heating gives CO2. But if you want to see the equation here, calcium oxide will be also another product. So the equation is your what? CaCO3 under strong heating CaO plus CO2. Look at that here, all are balanced. There is no necessary to balance again. Look at that here, one calcium, one carbon, three oxygen. This is your one oxygen, this is your two oxygen. So in both sides the elements are same. Now put the apply the stoichiometric relation. Here what mass is given, target is find out the volume. Look at that. If you think about the molecular mass of calcium carbonate for calcium 40, carbon 12, oxygen that is your 16, that is your 3 into 16. That means here I can say that 40 plus 12 plus 48. That means here you can say that 40, 48, that is your 88, 88 plus 12, that is your how much? That is your 100. So here I can say that 100 gram of calcium carbonate when undergoes heating, then 22.4 liter of carbon dioxide is produced. This is found in STP condition. Here STP is also the target. So calculate the volume of carbon dioxide at STP. By strong heating of 20 gram of calcium. Here 20 gram of calcium carbonate is given. Target is to find out the volume of carbon dioxide produced at a STP condition. This is the question mark. From the above equation, here I can write from the above 100 gram of calcium carbonate, 100 gram of calcium carbonate released or evolved CO2 at STP 22.4 liter. Next, 1 gram of calcium carbonate evolved. Carbon dioxide under STP condition is 22.4 divided by 100 liter. 20 gram of calcium carbonate evolved. Carbon dioxide at STP condition is 22.4 divided by 100 into 20. This is the equation. If you want to solve, then the answer is your 4.48 liter. This is the answer. So amount of carbon dioxide produced is your 4.48 liter. 4.48 liter. Next move to the last equation, that is your volume relationship. Problem number 1, here volume is given, volume is your target. Calculate the volume of carbon dioxide at STP produced by the complete combustion of 10 liter of methane gas. 10 liter of methane gas. Here methane gas means that is your CH4. Combustion means reaction with oxygen. Remember an important point. When any hydrocarbon undergoes combustion, then carbon dioxide and water is formed. This is the main concept. When any hydrocarbon undergoes combustion, then it gives carbon dioxide and water. If you want to balance this equation, here you can write CH4 plus 2O2 gives CO2 plus 2H2O. This is the balanced chemical equation. If you want to write the relation, here we can say that 22.4 liter of methane, then produce how much? 22.4 liter of carbon dioxide. For 10 liter, how much carbon dioxide is formed? Your target to find out the carbon dioxide released. From the above here, I can write 22.4 liter of methane produces carbon dioxide is your how much? 22.4 liter. 1 liter of methane produces carbon dioxide is your how much? 22.4 in divided by 22.4 liter. 10 liter of CH4 produce carbon dioxide is your how much? 22.4 divided by 22.4 into 10. 22.4 cancel. The answer is your 10 liter. So the amount of carbon dioxide produced that is your 10 liter. Next, move to the problem number 2. Calculate the volume of carbon dioxide produced by the complete combustion of 10 liter of ethane gas. Here ethane gas is given. The formula of ethane gas is your C2H6. Combustion means reaction with the oxygen. Then we know that every hydrocarbon, methane, ethane, propane, butane, pentane, hexane, all the hydrocarbons when undergoes combustion, it gives two products, that is carbon dioxide, another is your water. If you want to balance this equation, then the balanced equation is your C2H6 plus 2O2 gives 2CO2 plus 3H2O. Now apply the relation. Your coefficient 1 is given. So here I can write 1 into 22.4 liter. No necessity to write about something about the oxygen, because our target is find out the carbon dioxide. Our data is your given, that is your ethane volume of ethane. And so here I can write for carbon dioxide, here I can write 2 into 22.4 liter. Here the ethane gas is your 10 liter given data. Target is find out the carbon dioxide. From the above here I can write 22.4 liter of ethane produce carbon dioxide equal to 2 into 22.4 liter. This is the relation. For 1 liter of methane gas produces carbon dioxide is your how much? 2 into 22.4. That is your 2 into 22.4 divided by 22.4. Next, for 10 liter of methane produced carbon dioxide is your how much? 2 into 22.4 divided by 22.4 into 10. So cancel 22.4, 22.4, that is your 2 into 10 is your 2. This is all about the stoichiometric calculation. Actually, this actually in this problem create very difficult to solve, because here the data is in wrong form. So try to understand this problem. Otherwise, in the next class, I will again explain this problem. This problem take much more time to understand. So next period in the upcoming class, I will repeat this. I will correct this. Okay. Till now, I have already given the correct answer. So you see the answer. If you will not understood, in the next class, I will repeat about this problem. This is all about the stoichiometry calculation. Thank you very much to all. All are watching the video. So carry on the watching. Have a nice day.